Super short video here, Math 126 students on homework 14.7 problems 9 and 10. Sometimes students are confused by this. They're given some surface. In number 10, they're given a cone. In number 9, they're given a plane. You actually can do that one in more than one way. And then you're given a point. Sorry, it's spinning that around. So they give you this point, and they ask you the closest distance. So this is actually from an old exam, a visual I made, but I thought it'd be fun to see this. You're finding based off of the x and y location of this point on the surface, how far is that? So it is a straight line distance question. You're trying to minimize a straight line distance. The thing that's your constraint is that the second point has to come from this surface. All right, so you can see there's just a few examples of different xy points, and you're trying to minimize it. So you're constructing this function that represents that distance. Again, all these questions, the most important thing you should be thinking is, what am I minimizing? And in this case, it's a straight line distance that you're minimizing. You're going to solve it using sort of positive numbers, and you're going to find that, for the cone at least, you're going to find that positive solution wherever it is, and then find the distance. But you can see by symmetry that you could go the same distance to the lower half. And the lower half's the same, just if I made this negative. Then I'd be talking about the lower cone, and we could talk about that distance. So that's why there's two answers. That's just something that'll come into play at the very end of the problem. You'll have the one that has a positive z and the one that has a negative z when you go to plug it back in. Okay, I just thought I'm kind of enjoying making these little visuals for these problems. I think they're super interesting. I hope these bring these problems more to life for you. We could change the surface to anything else. We could be finding the distance to a paraboloid, anything that we have an equation for, and you could use the exact same method. So you are solving a whole general class of problems. You give me any surface whatsoever and a point, and I can find the minimum distance. That's kind of cool that this optimization method applies so generally to so many problems. Okay, hope that's interesting to you. I wish we had more time we spent on optimization. There's so much to say, but we just get a little taste of it here in Math 126. All right.